Check with her if it's online. Yeah, already got two. So there are two viewers. So, let's start. So your assignment is online, homework 3, and it's compared to the first two ones, it's little involved. You must have noticed it. So it asks you to actually start building applications which interacts with something outside of just the user. It's built on top of what I will teach today. So the first thing is you will, since you have taken the networking course, you know what sockets are. So you will use a library to create a socket, send a message using HTTP protocol. Like it's a short message. If you know the exact syntax, it's not hard. But you have to write it, open a socket, write that message. What you get back in return is the file that's stored at that URL. Right? So you should just get it. Right? You get that file and you go to a line number, which is what user selects randomly. Right? 10, 15, 11, whatever user selects, you have to show that line to the user. Then a second thing will be, instead of using the socket, now this script will get simpler and simpler. You have to use a socket. No, you don't have to use a socket, you just use HTTP library. So with that, you don't have to worry about creating a socket, opening a socket, right, sending a message. You open up an HTTP connection and send a message, which is also a very, very standard format, get something, and you will get it. Right? So it's simple. The first part is hard. Second part is little easy. Third part is, I think you have to parse that file. I forgot what is the third and fourth, but between these third and fourth, one thing is to parse the file. It's a JSON object, so you will get familiarized with JSON, and then you should be able to parse it using the library. You don't have to write a parser. Right? There are available parsers in Android. Use it, give this file as input, it will parse it for you. You will get a handle on all objects inside that. Take the object, that number, 10th number or whatever that ith number is, and you display one field inside that object. You must know HTML, right? Have you used HTML? At least you know the syntax. JSON is similar to that, it's a little different, but it has similar objectives. So that's parsing. And the last thing is, once you get this latitude and longitude, you have to call, no. So there is one which you have to go over. There is one more where you have to show this page using Chrome, right? And then the last thing is, once you parse it, you use Google Maps to show it. I know this is, as compared to the first two easy cakewalks, right? This will get complex, right? So I would recommend you start working on it as soon as possible. Don't wait till the last night, right? And then start doing it. Otherwise, I think it will be hard. Right? So your project thing is delayed. Although I have given you a link to identify project groups, you must have seen that I didn't mention any deadline for that. I did not ask you for the title of your project also, right? I just want you to get started forming the groups among yourself. You can discuss the project among yourselves, but you don't have to disclose it right now. It will take time. I might also suggest few more topics next time myself. On coming Wednesday, I will also suggest some topics of my own. I will also post them on the backpack discussion even before coming to the class. Some of you have already talked with me about some questions that you had about the projects. I mean, those who have still more questions and or those who haven't met me can meet me in the office hours on Wednesday. Or even if I'm here before, then you can meet me and discuss. So projects will take time. We'll finish it before mid-sem, hopefully, or even maybe later. Right? So that will take time, but this assignment is important. Any questions? This is also a right time to ask if you have any questions about projects. Not individual projects, but something that applies to everyone.
There is one general query we have put in that number of students in a group. So some are saying that we want 2 students in a group, some are saying 5.
So I had discussion about this. What happens if the number of students in a group is different? Like 1, 2, 3, 4, 5, 6. Then it becomes hard to be fair in evaluation. Some group does something, let's say there are 5 members, and there is another person single-handedly does the same amount of say. What should I do? Right? I know that I should just set a bar and give same marks, but it's not really something I will do, because finally one student is putting so much of efforts. Right? My tendency is to give him some more marks. Right? So that's why I said let's make it fair so that every group is 5 members each. So that then I can compare across the groups and see if you have done something and I can compare. Otherwise, the other option is every person does a project on the topic that I give. You can of course extend it, but whatever I say, you have to do it, right? And then again, that entire thing, the category will have one member each. So again, I can fairly evaluate it. Right? So that's the reason. So having less than 5 members will again get me into the same issue and problem. So I don't want less than 5 members. Right? Some of you are saying that I want more members. Unless the project really demands it. If you have 6 members, 7 members, right? You should then develop a lot of things. Because everybody is getting individual credit for that. Right? It's 6 times the individual efforts. It's not. Right? So I don't think you will actually start with something which is so big at the beginning. But if you have a really well thought idea and actually I feel that you need more people, then you can talk to me. Less than 5 is something which will be hard. Okay, so that's one question. Another thing is, see, you just started with Android, so I understand that you will not be able to see the whole Android and then start a project, right? So, but you can start with something if later on, and if it's really right courageous, that you decided, okay, I want to do something which is very big, and I also encourage you. You start with it, and later on you find that it's not really possible. It's not your fault. It's something that's not possible. Some API is broken. That will happen if you select the latest Android and you land upon an API which is not supported well. It might happen that you will not be able to proceed further. Then there are some minor changes which are okay. You can talk to me and we will change the course of your project. That's okay. It's not like you signed up for this. No matter what Android provides you, phone provides you, you have to accomplish it. It's not like that. So all those changes is okay. The other doubts? So I think I'm done. So let me start with this. So today I will touch upon 3 topics, right? And these 3 topics are, as I said in the for the assignment, it gets you and starts you interacting with the internet, which is there is lot of more information than what you have on the phone. Right? So you want to utilize information on the internet. Second thing, it allows you to get your location. This is what we saw in that first lecture about ubiquitous and pervasive computing. You want scale and you want location. Right? So I will tell you about different ways of getting locations, what are the advantages and disadvantages and trade-offs. The third thing we will look at is sensor. That's again you interact with the physical world. So far, whatever programming you have done for first 2 years for desktops and laptops and server, it's mostly one computer and you process something. Right? With the sensors advantages, you actually connect the digital world to the physical world. Something that happens in the physical world, you sense it and you do something in the digital world. So that also brings a lot more information than just what's there. The first thing is location, and I will not go through the syntax because that you can actually very easily go through the APIs and find out. So mobile application, if they get knowledge of location, you know how it will enrich their power. Right? Their whole context is changed, and the decisions that they will make is better. For example, if my phone knows that I am inside this room and there is a laptop and there are so many students, it can actually just go on silent first of all, right? And then if I am in the class, then I might want to open PowerPoint, right? So it can act as a remote for PowerPoint, and it can do lots of things automatically, which otherwise take a lot of time, right? So location adds value. Another thing is there is a concept called geofencing. So fence, as you know in English, it's something where you surround an area, geographical area, right? So geofencing is something where you can virtually create a boundary around this area. Let's say I create a boundary around this area, which I say classroom. Then I might create a boundary which will say this is campus. Then I create an area around a place which is a market. Right? And depending upon whether I'm inside the market or outside the market, the phone will act differently. Or if I'm inside the classroom and outside, the phone will act differently. And there are inbuilt APIs for you to exploit this concept of geofencing. You can tell Android phone that you are within so much of meters or so much of kilometers from the epicenter of this. Then do something, otherwise do something else. So you just tell it once to the phone operating system, and the operating system will take care of it and inform you whether you are within the boundary or outside the boundary. So for example, yes. No, the simplest form is circle. Typically, you use circle. For using anything other than the circle, a geometrical shape, it becomes complex. I don't think Android will support it. You need far more complex libraries to support it, right? But it's possible to do that. For example, a building will not be a circle, a river will not be a circle, and so on. So there are ways to even handle those things. So another example of this is Foursquare. Right? Once you go inside a restaurant, it detects it that we are within the restaurant, as opposed to just outside, and then it allows you to check in, saying I'm in that restaurant. So typically, when we say location, it means we have latitude, longitude, and this is a unique position on the entire planet where you can say, okay, this is where I am, and it's very accurate. And this is typically received by something called a GPS. What is the communication of GPS? Do you know how does it get a location? Triangulation of what? Yes, 3 coordinates. Okay, but how does a phone get? Phone is at one place. It's not at 3 coordinates. Signals from satellite, right? So there are geostationary satellites floating around the Earth, and their locations are fixed, right? Depending on which satellites you're seeing, right? You can then find out where you could be. So to give you an example, right? If you see satellite A, then its area of coverage is this much. Right? Then you see satellite B, its coverage is this much. And depending on more satellites that you see, right, you can keep drawing these circles on the surface, and they will have a common surface, an intersection. This is where the intersection is. Right? And that's how you can get a location. So you should be able to see lots of satellites. So when would this system fail? But I have enough satellites in it. Right? So let's assume you have enough satellites. Okay, when will signal strength be low? So what you're saying is you can't see the satellite. Close area, this area. Right? This is inside a room. I don't get a good reception of signals from satellites within the building. Right? Then you get a blind spot there. And your GPS is then what? So there is something called, I will introduce this term again. Yeah. Maybe I said accuracy. What if I'm seeing, let's say, 20 satellites as compared to 5 satellites? What will happen? Your accuracy will vary. If you are seeing more satellites, then your intersection area and your confidence in it increases. But if you see less and less satellites, for example, like this area, your GPS knows that it is trying to get a location by finding intersection, but it says the accuracy is low. I'm not seeing that many satellites. So every location that you see comes with two values. One is the actual location, right? And what is another thing important is accuracy. How much accurate it could be. In physics, it's typically called precision. Every instrument that you have in physics to measure some physical parameter has its own precision. Vernacular compass, everything that comes, it comes with its own precision. Similarly, every location system has its own precision. Other things you get is timestamp, which is easy. What is the current time? Altitude, what is altitude? The height. And it can not only tell you that you are here in this location in Ookla phase 3, But if this there is it's above certain height, like it's at certain altitude from the sea level, then it can tell you that. It can also tell you speed. If you're moving, it can tell you what is your speed, meters per second. Right? And let's forget about the bearing part. But these are the important ones. That with this information, you can see you can build lots of intelligent apps. For example, the speed can be used to find out whether you are in a bus, or whether you are traveling inside a vehicle, or you're walking, or you're standing, right, and all that. You all know GPS satellites. Another technology in the phone is cell phone towers, and then there's the last one is Wi-Fi access point. Can you now tell me how would the same technology, same idea, algorithm can be applied to these other two technologies? I told you what is the idea of getting location using satellites. You just to talk to your next neighbor and think of a technology or an algorithm like this, which will give you locations using a cell phone, towers, and using Wi-Fi. Just talk to your friends for a couple of minutes, right? And I can then ask any one of you. I will ask any one of you. Tell me how can you get it? Okay, can I ask anyone now? Are you ready? Okay, good question. Hmm. That you have to think about it, and that's how you think. Whatever you know about Wi-Fi and access point, you think with that level. I know you don't fully know Wi-Fi. Whatever you know from it. Okay, ready? No, no, next, front of you. Can you tell me how would you use a cell phone tower to get a location on the phone? Yes. Yes. Yes, that's good. Right. So your phone is within the range of multiple cell phone towers. Right? You can see sometimes your signal bars are very good, sometimes bad again, and then again very good. Because it is fluctuating different towers. It's sometimes connected to the tower on the right, and otherwise to the left, then back and forth, and so on. Right? So it is constantly hearing all these towers, and then whichever is giving us is the signal strength, which is how good it can hear that tower. It is selecting it. So what Android operating system use, it's the same concept. Instead of this GPS satellites, you have cell phone towers. Right? And then every cell phone tower, you know, I can hear this tower, I can hear that tower, right? And then there's something still I'm hiding, right? But then if you can circle around this area like this, in this region, right? So if I'm hearing this at a signal strength of some value, I could be at a distance this much from B, right? And then if I'm also hearing A, then I could be at a distance this much from A. And then I also get C, right? I can be at a distance this much from C. And so on. You can start drawing these lines or part of circles, right? And then wherever all intersect, this is where you are. Okay. Now the question that I did not talk or I did not tell you one information is, how do I know where to draw that line? How much distance I could be from that tower?
Time it takes from signal to that radius, then here we can draw the sphere. With one point we can draw sphere, with 2 points.
Right. That's one way. That's a very good way. You can see if I shout and you echo it back to me, I can see how much time it takes. And it's the radio frequency. It's very hard to get accurate value because whatever you talk and the tower is talking is at the speed of light. So even an error of microsecond in terms of distance is long. Right? So your phone has to be really, really accurate. And its clock has to be also very accurate in doing all this. So for example, if your phone is slow, then that would add delay. But that delay does not mean you are longer distance from the tower. Right? So that will add lots of error. Okay, so how does Google does it? It's a good way, scientifically correct, but sometimes very hard to achieve using a phone which is less than 3,000 rupees. It really can't do it. You need very good crystal to look at time and find out the distance. So how does Android do? Any guess? I think I told you, I gave you a hint. Or even Kuldeep gave you a hint. It uses signal strength, but it uses some idea from Google which they apply everywhere. And there is one principle that the whole company of Google is based on. Yeah, right, very good. Yes. So exactly what he said, right? If you have a phone which has GPS on, and at that time you measure which cell phone tower can you hear from what signal strength, you get a translation between the exact latitude, longitude, location, and the signal strength of 3 different towers. So next time anybody gives you the values of 3 different towers with signal strengths, you just look at this table and say you must be at this location. That's it. This is what Google does. So when you buy a new Android phone, you see a long agreement, contractual agreement, and you just say agree. Or it is also asking you in between is whether it's allowed to sample this. When your GPS is on and you are getting the signal strength, can I send it to the Google server and keep storing it? Right? So next time somebody asks me, I just look at that table and convert it. And the reason I say Google does this is something which we say also big data. It's because, see, Google can translate from any language to any language, right? As a machine. How are they doing it? They're doing it because, Kuldeep gave an example that day, the way they translated all the books, they actually used human, right? So I said this is, in Hindi, it's written this, so I as a human translate it and write it in English, and they store all these mappings. So next time anybody asks me a sentence or a word, Google will look into this, search it and say, okay, this is what the translation is. They don't understand anything of the language, right? That machine is not smart enough to understand language as we humans do. It has just a lot of corpus of data which has all possible combination and it can search it very fast. Okay. So that's how Google did it, and that's how we do it for cell phone. And anybody wants to take back at this Wi-Fi access point. How do you localize using Wi-Fi access points? I can then pick some. How would you do Wi-Fi access point? If somebody from that end. Anybody wants to say yeah? Yes. 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 Right. Very good. So you use same concept of signal strength, and the idea of the access point is its MAC address. So you don't call it using cell phone tower, you don't say it's GPS satellite. The MAC address of this access point is this, right? So this is how you get unique, and the access point, the MAC addresses are globally unique, right? So once you have, either you do the same time calculation, time of propagation, and how much is the distance, and then the circle around it, or you use Google's method, right? You just keep sampling. Your phones are continuously sampling, and again giving this information to Google, and Google is storing it, right? And this is the rich data, and whenever next time somebody sees the same access point, it will say, the system will say you are in triple IT Delhi. Because it knows if you are in triple IT Delhi with these GPS coordinates, you see these access points, right? Now the hard part is if I take all these access points from here and take it to your house and keep it there, and then if you go there, it will say you are in triple IT Delhi. Because the system only sees the MAC addresses. Okay. So these are different technologies, 3 technologies to get location on a phone. Yes.
So we have to consider a remote problem. But if the second between the AP and our mobile, the signals will be very.
Yes. Right. So that's why it's not very accurate. But one thing, it builds on the principle that there are lots of access points. Similarly, there are lots of cell phone towers. If you are in an area, a remote area, where you don't have cell phone towers, right, you don't get location. Similarly for this one. As long as you have many of these, then only it will work. And the more you have, the better is the accuracy. So that is how it will work.
Can we be connected to more than one access point?
So that's a different question. It's a question we will address in the network when we start looking into mobile networks. Okay, but
What if we can't more than one?
right. Right.
Like you said, set of access points.
Right. So I will just give you a very short answer because this is not the topic of today's lecture. And I can hear everybody talking, or at least I can know that if somebody else is also talking, but I can right now only hear you. It's the same principle. I can see that other towers are there, but I will pick one as a phone and I will only communicate to that, and the other gets ignored. But you know other things are there. Okay, so there are. So when you say you want network-based location, that means you either use Wi-Fi or the cell phone tower. If you say I want GPS, there is a satellite-based location, and then there is another location which is passive location. So this is, you actively get location. I want location, give it to me. So phone has to do the triangulation, mapping, whatever it wants to do, and give you a location. But when you say in the application I want passive, that means you say there are hundreds of other applications running on the phone. Everybody is asking you for the location. Don't go there and give me a location. Whatever the latest application who got the location, just give it to me. And so this is piggybacking. You don't ask the phone to actively right now get a new location or correct location. Whatever was the last recorded location, because some other app asked for it, just give it to me. Now, which is the more energy efficient? The last one, right? So this is how your app can be more energy efficient. And there could be apps from a developer who's naive you will always get location fixes again and again, right? And that will drain the battery very fast, right? And the other app could be smarter, and it can say that passively give me the location if accuracy is sufficient enough, or if the timestamp is sufficiently latest, I will use it. Otherwise, I discard it and then I get a new location anyway, right? But if most of the time I am getting a location which is sufficiently accurate and sufficiently latest, I save a lot of energy on the phone. And GPS actually consumes a lot of energy. If you continuously sample GPS, your phone will not last for more than few hours, and it will die immediately. So coming back to the permissions, you can either get a post location or a find location, right? And you have to tell to the operating system that which one you are interested in, and you get a permission for that, right? So the user also gets a prompt that this so application is looking at GPS, and it wants to get the location. When the user approves it, app gets installed, and then you get a find location. So GPS will be find location. Passive provider can also be a find location, right? So you are interested in find location, but in a passive manner. Whoever is getting it, you just piggyback on it and get it. So as I said, there is a trade-off between the cost, accuracy, availability, and timeliness. Depending upon which technology you select, right, you get what a trade-off between all these things. Yeah. Whenever you get a location, you get all these fields as in latitude, longitude, timestamp, accuracy, speed, altitude, right? So there is also a timestamp. Location is always, it comes with a timestamp. So you can compare with the current time and find out whether it's latest or not. So typically the cell ID based thing is course location. Right? So you say I want course location, and then you can go to, it will take you to the cell phone ID. Right? But when you say find, right, it knows that most of the time it has to be GPS because the accuracy requirement is strict. Okay? So depending on, so what is happening, there is a service continuously running which is getting this location a lot of times, right? And so depending upon what applications are demanding, find or course, operating system can actually put something to sleep. For example, it can switch off the GPS chip if everybody is looking for course location. It comes through the Wi-Fi access point. So if your Wi-Fi is enabled, and cell ID is always enabled, other than when you are completely offline. Your cell phone tower is continuously on and talking to the phone. Right? So that location is always available. Right? So GPS is expensive. First of all, the chip is expensive. They are using certain phones. It is accurate. It is slow because it takes time to get fixes from the GPS satellites. Right? It's very far. And then it is mostly available outdoors. Indoor is an issue. Network is cheaper, less accurate. It's faster and availability varies. Right? So network includes both Wi-Fi and cell phone tower. And passive is best. It's cheapest, fastest, but it may not always be available. Fastest doesn't mean you immediately get it. Right? I'm not saying fastest, it's latest. It may not be latest. Okay, so if you are doing it in a project and you want a location, if you have an idea about all these options which are available and trade off between this, right, then you select the right one so that you get the optimum battery also and accuracy also. Okay, let me see if all of this is syntax, then I can skip it. So this is what I talked about, the geofencing. Right? You can tell the operating system that I want location, give it back to me right now. You can tell at some frequency I want locations, or you can say if I am near this much distance, if I am within 1 kilometer from this point, then inform me. This is the geofencing. Right? So now you can tell operating system that when I am within 1 kilometer of the metro station, inform me. Right? So that is a different thing. So what is an advantage of this? How can you do the same thing using some other API? So the objective is you want to find out whether you are within 1 kilometer of metro station. If you don't have this intent and right, this concept, how would you do it? What would be the naive approach? And what will you do with the GPS? Service, and how would you get it?
Get the location of metro station, then ask
Right, and how often do I have to do this? Every time. So that's the while loop. Right? While true, keep doing it. That's busy coding. Right? You continuously look at it, and the disadvantage you all know that whenever you write a while loop which is true, right, with something, that it will drain the battery very fast. Right? As compared this way, where you just scan the operating system once and you tell him just give me a call back or notify me whenever this happens or anything, and then that becomes energy efficient. So when you develop an app this way of continuously looping it, right, nobody is giving to give you any error. It's just that when you install the app on the phone, your phone battery will die within few hours. Right? It will still work correctly, but the battery will be gone. With this way, your battery will last longer and you still achieve the same effect. Right? So this is how you can register for an intent, and then the intent will fire and you will know whether you are within that area.
So is the intent reliable, or will it sometimes miss alignment?
That's so this is reliable as much as the first option. If you're going to miss it anyway, using this also, it will also miss. But if that option is going to catch it for you, this will also do it. Right? So that way, so operating system is not going to pay any spoils for indication. As long as GPS chip is there, it is doing the job, it will do it. Right? So the accuracy is the same. So you can have something where you say is you can register for even things like whether the location is changed. Right? You can say this is the location, and if your location changed, right, let inform me. If some provider gets disabled, Wi-Fi or something, GPS, the user switches off the GPS. And he doesn't want to, he manually goes to the security, the configuration setting, switch off the GPS, right? Then also you can get notified. If you want to do some, take some action on that, you can do that. If provider gets similarly enabled, you can get that, right? And if there is some status change, like the accuracy has changed for some provider, you can get an event back also, right? So there are lots of ways where your application is aware of what's happening for the location. And if the more conditions you handle, your app becomes better and better. Right? So the best one like Foursquare, they handle all these cases. And that's why their app is so accurate and doesn't crashes a lot of times. So to summarize, what are the factors you should consider is measurement time. Like GPS takes long time sometimes. It doesn't have a fix. Your app has to wait. Accuracy, what accuracy is what you want. Right? If you want to find out your application demands something which is of the accurate of few meters, then you should use accordingly. And then if you want to optimize on the power, you also use accordingly. Okay, so next topic is sensor, which is very close to GPS, because GPS is also a sensor. A lot of times we call GPS also a sensor because it is sensing signals coming from the satellite, right? It's not really a communication. We will see it's almost similar to the GPS. A lot of things you will see is the similar things. How you get it, the frequency of it, and when something changes, accuracy, because every sensor has its own accuracy. So most of the things that you see in location, that is also all there in this one. So what sensors do you know on a phone? I want to get the entire laundry list of all the sensors that you know. Accelerometer, axle, gyro. What is gyro used for? Orientation, right? The rotation mostly. If you're playing a game, right? The rotations. Then what is the next one? Connect. Proximity. What is proximity?
Distance of the body.
From the phone, right? If you are holding it near to the ear, that tells using proximity sensor how close the phone is to your body. That's so you can switch off the screen. Next, magnetometer. What is magnetometer for? It's used for compass, but what does magnetometer tell you? What does it measure? The magnetic field, right? So just like acceleration tells you in three different dimensions, x, y, and z. What is the acceleration? Earth has its own magnetic field, and depending upon how you are holding the phone, Earth's magnetic field has an effect on the phone, and it tells you what is that effect. Okay. So magnetometer. Next. Anything next? Raise your hand. Light sensor. So if you are in the dark, the screen glows more, right? And if you are in very bright, right, you don't need that brightness. Anything else? I think you missed the first one, which heart rate. It's not there yet. It is expected probably when the iPhone 6 comes. Yes. Mic, right? Right? So that's what I said. You're missing the most important ones. That's right. You can miss. So these are, I mean, this is how they are so integral part of the phone, right? You don't even call them as a sensor. Those actually are phone. Okay, so camera, touchpad, mic, accelerometer, gyroscope, proximity, magnetometer, mic, right? And then compass is a combination of two of these. This magnetometer and the gyro, and then you take a compass. Anything else? Yeah. Barometer, some of the phones have barometers, which gives you pressure. Anything else? Fingerprint, biometric sensor. Right? iPhone 5 has got a biometric sensor where it can detect your fingerprint. How much? Right, get heat sensor. So I don't think there is really temperature sensor. Every processor comes with a temperature sensor of its own. For the purpose of it is not overheating. That's there, but in the processor, it can't really tell you what is the ambient temperature. Every processor has a sensor to make sure that the processor is not heating up beyond certain threshold. Yes, it's there, but it's not really for the user. Right? So you see, there's so many sensors, right? And you can use any one of these. And then when your app will become so rich, it can interact with the physical world using these sensors, right? And you can get most of the things, motion, position, environment, and you get knowledge about all of these. Right? So the three ones that we are using in this as example is accelerometer, magnetic field sensor, which is magnetometer, and then a pressure sensor, right, which is the barometer. And so these are the three ones that these slides are talking about. So how does a sensor combine with your program? So far, I don't think we have written any program in your first year and second year where you actively use sensor. This is from your 12th standard physics, right? What happens if I drop it? I know it might break, but other than this, what will happen from here to the ground? What will be its acceleration? G, right? So the G force. What is the force I am putting on the phone so that it does not get dropped? Same G in the, right? So I am acting G in the other direction. So this is what the force returns. If I read the acceleration value right now, right? I'm actually stopping the phone from accelerating at 9.8 meters per second downwards. Right? So phone is actually getting accelerated at 9.8 meters per second in the opposite direction. Right? So it tells you that. And in the other two axes, there is no force acting. Right? So it's zero. Right? So you get these values. Okay, so you use these values and then you can do experiments. Like you can actually say, okay, I will walk at the rate of 1 meter per second. Right? I'm walking at the speed of 1 meter per second, and then you see how does your phone will tell you in terms of acceleration. And then you can bring in all the physics of integration, derivation, right? And you can convert it between distance. How do I get from acceleration to the velocity? What do you do? Stop your memory, 12th standard. I have accelerations. How do I get back the velocity? You integrate it, and from velocity distance, you again integrate, right? And this is what you can all do now. Once you get these acceleration values, you can do this reverse, and you can get the first order thing, which is the speed or velocity, and the zeroth order thing, which is the distance, right? You can go back. Right. So here. Right. So this is an example. You see, you get a very accurate value, and if you continuously run this app, these values will constantly change because physical world is not digitized. Right. It acts at a very high rate, right, and we can only sample it at certain points, and these values will continuously change. Right. So this is what you will get. X is 0 meters per second square, Y is 9.81, accurate one, and Z is 0. Okay. So, if you're doing these assignments, two important concepts you should take away from this class is you should know what this low pass filter is and high pass filter is. How many of you have heard these terms? Have you? What is? Then you can tell where you will use a low pass filter. Yes, one, maybe at the last 2 rows. Anybody tell me what is a low pass filter? Anybody from there? What is a filter? You can tell me what is a filter is, and then I will help you with what low pass is. What will filter do from the sensors? What is your guess? Yes, so filter will actually delete some part of the stream that you're getting. You're getting a stream of data, and then filter will act on it and it will delete something. Okay, now coming back to where the low pass and the high pass is. Right, so every physical phenomena that you see have two things. One is there is something which is changing very fast, and there is something which is changing slowly. Right? And there is summation of these two. And there are of course multiple variants, not just one black and white binary, low and high. Right? So if I'm talking, right, how when I talk, what is happening? In the biological terms, right? There is something in my throat cord, right, which is vibrating, right, and it is vibrating at a very and walk again. I'm not interested in that form. And I'm interested in that smooth walking and how long you do it. Right? So which is the filter you would use now? Since you know what high pass, low pass filters are, if I want to know the slow walking, which filter? Low pass filter. That's a low frequency thing. Right? It's not a noise. And for the other activity, right, you will use a high pass filter. So for every sensor you will see either or right, you can't focus on both of these things because then the data becomes noisy. Right? So you decide upon what you want to measure, which sensor you should use. You use the right code to get this filter. This code is easily available, right? And then you train the systems to detect that changes and you use it. Okay. The questions. So can you give me an example for the light sensor? What could be a phenomena where I will use a low pass filter, and what would be a phenomena where I will use a high pass filter? You're looking at light, right? What is right? So as the day progresses, right, it slowly changes. That's no change. And what would be the sudden change? Fluctuation, right? Every light bulb might have some fluctuations, right? You may not be able to see it, but the sensor is sharp enough to even notice that this bulb is like fluctuating, continuous. Okay. Any doubts about this, the GPS? And you get the values in the same manner like GPS. You register for a callback, and whenever the value of the sensor changes, you can see give it back to me, right? And you will get an accuracy value and everything. And then you use it constantly. Right? It's the same way. So if you know how to use GPS, it will be easy for you, very easy for you to also use a sensor. And then this is the last part. And then okay. So this, by the way, we will come actually look at detail later on. And when for you to get started with your projects, I thought I will quickly talk about this. Right? But we will go into all sorts of mobile protocols, and you will see what is the design behind it and what is the mobility, how complex the mobility could be, and so. Where the phone is situated right now and what is happening in that environment. And third thing is, still the phone's knowledge is limited. Right? It only knows its location and what is happening in that environment. Right? There is a lot of information in the internet. There are different protocols. It started with 2G, like then 3G, then now it's the LTE. In US, almost everything has migrated from 3G to LTE. In India, we are still, the 3G penetration is not much, but some of the cities already have started migrating to LTE. Right? And then there will be 5G, which is there on the horizon. Right? So the network is getting faster and faster, and you have better access to the internet. So anything that you want to connect to the network, you should know what socket is. For any information you get from the internet, you create a socket, you open a socket, get information through the socket. I will not talk about socket in this class. This is dealt in detail in the networks course. So I will not touch upon sockets. We use HTTP protocol for most of our installation, right? Then